There's a strange truth buried in the field manuals and forgotten engineering notes from the Second World War. Frontline soldiers were constantly exposed to cold that froze equipment, slowed reaction times, and honestly threatened their lives long before a bullet ever did. Yet some of the most effective heating tricks developed by military engineers were never widely issued, never standardized, and in some cases never even shown to the average infantryman. These weren't experimental gadgets or classified heaters. They were simple, clever, field-ready methods that required no electricity, minimal fuel, and relied on physics, insulation, and the resourceful materials soldiers always had around them. What makes them more valuable today is, well, their practicality. Whether you're studying wartime engineering, restoring an old shelter, or looking for emergency heating methods for a modern grid-down scenario, these overlooked Second World War techniques still outperform many modern so-called survival hacks. The trick of layered heat retention was more powerful than any field stove. One of the most effective heating approaches used by engineers involved creating layered heat pockets rather than relying on a single heat source. Instead of trying to produce a large flame, the goal was to trap and recycle the small amount of heat already being generated by the human body, or a tiny flame. Soldiers who understood this method dug shallow depressions in the ground, lined them with dry materials like straw or bundled cloth, and created a double wall around their shelter, often using spare boards or even stacked ammunition crates. The air gap between the two walls acted as a thermal buffer, cutting heat loss dramatically. Modern application is simple. If you're trying to warm a small emergency shelter, create an inner wall using cardboard, scrap plywood, or even blankets hung from lines. Leave a narrow air gap between the outer and inner layers. This small detail cuts heat loss by as much as 30% and requires no additional fuel. It's a perfect example of passive heating, relying on insulation strategy rather than combustion. Engineers relied on rock preheating when fuel was scarce. Many units operating in mountainous terrain used a method that was centuries old, but, rarely taught to frontline soldiers. They heated small stones in low flames or embers, then placed those stones under bed platforms, inside pits or near tent walls to radiate heat for hours. The trick was choosing stones that wouldn't crack or explode under temperature shifts. Basalt, granite, and river-rounded stones were ideal. This works today in off-grid cabins or survival camps. Heat stones gradually on the edge of a fire, not in the centre, then rotate them every few minutes to build heat evenly. Once hot, move them carefully using tools or thick cloth and place them where radiant heat can spread without risk of fire. A few properly heated stones can maintain noticeable warmth through most of the night. The charcoal trench method was a forgotten battlefield heater. In areas where smoke discipline mattered, open flames were avoided. Engineers taught select units to dig narrow trenches, fill them with a controlled layer of smouldering charcoal, and cover the trench with metal scraps or thick boards. Soil was piled on top, turning the trench into a long, low-emission radiant heater. The soil insulated the charcoal, allowing it to burn slowly and evenly while producing almost no visible smoke. Anyone working on a modern shelter can recreate this system safely by constructing a trench outside the living area and routing the heat inward through vented stones or metal. It's essentially a ground-based radiator, ideal for discrete, fuel-efficient heating. Heat recycling through reflective barriers was one of the most efficient field hacks. Some engineers noticed that heat loss wasn't the real issue. Poorly directed heat was. They started using reflective surfaces, often scrap metal, polished mess tins, or flattened food cans, to bounce heat back toward troops or into enclosed spaces. By directing a small flame toward a reflective wall, they effectively doubled the perceived output. In a practical sense today, placing a reflective panel behind any safe heat source amplifies the warmth dramatically. Aluminum foil, metal sheets, or even emergency blankets can create a radiant pocket, focusing heat where you need it instead of letting it dissipate. Units stationed in wet or cold regions often built clay-sealed microchambers. These were small pits or dugouts lined with thick clay walls. Clay holds heat well and slows air movement, which allowed a small ember bed or tiny flame to produce significant warmth. Soldiers without access to clay often found themselves in a bit of a bind, didn't they? They cleverly substituted mud mixed with ash to create a rather crude yet effective insulating composite. Now, recreating this is surprisingly straightforward. It requires nothing more than a small pit and some good, clay-rich soil. Once it's hardened, this chamber retains heat quite effectively, I must say. It can even run safely with just a minimal flame. It's actually one of the most durable low-tech heating techniques from the war, you know. Hot water mass warming was a clever trick used mostly by medics and engineers. Medics, well, they understood thermal mass better than most soldiers. When they needed steady heat that wouldn't flare up or burn through fuel, they'd fill metal canisters with hot water and store them under blankets or at the foot of beds. Water, you see, retains heat longer than nearly any material soldiers had access to, making it an efficient and safe heater. Today, filling metal bottles with boiled water and placing them strategically in a tent or shelter, well, it transforms them into slow-release heat batteries. It's actually one of the easiest off-grid heating methods available. Subterranean heating pits were built to warm shelters without direct flames. Some units built small subfloor heating pits beneath makeshift bunkers or supply sheds. These pits held low-burning coals or embers, and the heat, you know, slowly rose through the ground into the shelter above. Proper venting was crucial, which is why, you know, this technique was usually handled by engineers rather than infantry. When built correctly, these heating pits produced long-lasting warmth without direct exposure to fire. Modern application requires caution, but the principle remains sound. Heat rises through soil gradually, creating a stable, low-risk heating method for semi-permanent shelters. These 7 overlooked techniques show how wartime necessity pushed engineers to think differently about heat. They relied on physics, insulation and heat retention rather than high flames, and those same principles still offer reliable off-grid solutions today. If you enjoy deep dives into forgotten wartime engineering and want more practical history like this, subscribe to In the Beginning and share this guide with fellow history enthusiasts.